Hello, Space Cadets, and welcome to Mueller Planetarium Astronomy at Home. This is Zach Thompson, Planetarium Coordinator at the University of Nebraska State Museum at Morrill Hall in Lincoln, Nebraska, wishing you all clear skies. Today we're going to be exploring how to determine which direction we're facing just by using the stars. And to do this, we're going to be using our friend Stellarium. Look to the right of your screen where you'll find the web address being held up by our star buddies, stellarium.org. Go there to download for free the desktop or computer version so you can follow along with us at home. We wait till it gets nice and dark out. We direct our attention high up overhead into the sky, and that's where we can find a wonderful group of stars known as the Big Dipper. 7 stars make up a spoon in the sky. 1, 2, 3, 4, 5, 6, and 7. If we use our imagination, we imagine that this is the bowl, and these 3 stars are the arcing handle. The spoon is pouring its water outward into the sky. The Big Dipper is, of course, not a constellation. It's actually part of something larger known as Ursa Major, or the Big Bear. The Big Dipper is just the easiest part of this constellation for us to see. Now, when we find the Big Dipper, we locate these 2 stars in the bowl, and we point them down as a straight arrow or a line. And when we do that, we find this star, Polaris, the North Pole star. You can find this any time of the year as long as you first discover the Big Dipper and follow the direction that the water is pouring out of that bowl. In this case, it's out and down, and that's how we follow these 2 pointer stars to reach Polaris. What is so special about this star? Is it bright? If you're looking around the night sky, you will see many, many bright stars, but Polaris really is not one of them. It is not among the brightest stars in the night sky. But what is special about Polaris is where it is. Let's bring up our cardinal points. You notice here we have N for north, and Polaris lines up very well with that. So long ago, observers, navigators, and explorers were very good at seeing the night sky and watching for patterns and watching how things changed over time, and they noticed that throughout the night, and indeed throughout the year, the stars themselves looked like they were rotating around Polaris. The stars are not actually rotating. This is just the Earth spinning from east to west is the motion that we see. But as you start working your attention inwards toward Polaris, you see that it seems like it's fixed. It's not moving, but everything else is going around it. And it also points north. Because of all of that, it was this reliable marker in the sky. If you were lost, you didn't know which direction you were heading, you could figure this out as long as it was clear and dark out. You just needed to look for something familiar, in this case the Big Dipper, and then point to Polaris. That's probably one of the easiest ways to do that. And that still works to this day. You might be in a situation, who knows, where your phone is not charged all the way, you don't have any access to data or GPS signal, but you need to know where you are, where you're going. This is a surefire way because the nice thing about the stars is they don't need the internet to work. They are on all the time as long as it's clear and dark. Now, what is great about Polaris besides just the star here is it's another easy way to find a constellation called Ursa Minor, or the Baby Bear. You could also refer to this as the Little Dipper. But none of the stars of this constellation are very bright. That's why it's easier to find the Big Dipper and therefore the Big Bear, then find the small version of it. If you find one, it's not too hard to find the other. And then just to use your imagination, here's one way to think of them, the Big and the Little Bear. Let's go back to Polaris here, though. We said that it doesn't seem like it moves, and to the casual observation, it really doesn't. However, there is a point, an invisible point in the night sky known as the North Celestial Pole, as we bring it up there. Polaris is very close to it, but not exactly on it. So actually, throughout the evening, Polaris really is slowly but surely moving around it. But because it's so close to that point, it just seems like it's fixed. You just don't really notice it that much. Now, what exactly is the North Celestial Pole? Let's imagine, using this visual from our friends at NASA, the Earth, the round Earth. We know it has a north and a south pole and an equator. What we then do is we expand those points outward into space, pretty much forever, and we have what's called the celestial sphere. As you see here, there is a north and south celestial pole and a celestial equator. The easiest way to think of what the celestial sphere is it's the backdrop of the sky. Imagine that the stars are wallpaper put up inside the sphere that we can see, so that they appear as fixed points. But from our vantage point here on Earth, especially here in the northern hemisphere in Lincoln, Nebraska, this is how the tilt of the Earth orients everything for us. And indeed, we bring up the celestial sphere itself, and we have this kind of big wheel there in the sky, but all the stars appear as just imprints along the sphere. But really, we're interested in this point because it shows you where you are, which direction you're facing, and that's extremely handy. If we were to change our location, let's say, as we're still here in Lincoln, Nebraska, our latitude, our north-south location is about 41 degrees north. If we went somewhere else on the Earth, if we changed our longitude, our east and west, but we still were at about 41 degrees, watch the North Celestial Pole. And it might help if we bring up those constellations just to give you another marker in the sky. We go east, and yes, the constellations do shift a little bit, but that's just because of the time difference. The North Celestial Pole is pretty much fixed at that same latitude. It's that same altitude or height up there in the sky. And what that means is that we can be here in Lincoln, Nebraska, you can be over here in Europe, you can be over there in China. As long as you're at roughly the same latitude, you will see the same sky at night. Let's go back to Lincoln, and if we start going north of this location, now watch. The celestial pole, the North Celestial Pole, starts to move higher upward in the sky, and then when you're at the North Pole itself, it is directly above you. If we go south of Lincoln, we head towards the equator, we start to see that the North Celestial Pole gets lower in the sky until you are right there at the equator. The Celestial Pole is at the horizon. We will turn our sky around, and you're going to see that to the south, there is a South Celestial Pole that starts to come into view. The farther south we go, and there it starts to rise. So basically, as we move into the southern hemisphere, we are seeing a different part of the celestial sphere. We no longer see Polaris. We no longer see the North Celestial Pole. But this is where the South Celestial Pole starts to rise. The farther south you go of the equator. Notice here now, there is no star like Polaris. Nothing that's very close to the South Celestial Pole. So we're actually very fortunate in the northern hemisphere that we have a Polaris star as a marker for us. Our friends in the southern hemisphere have to do a little bit more to figure out which direction they're facing, but they have ways that certainly work. However, maybe not so easy or as apparent as a wonderful North Pole star. So the next time you're out there looking up and enjoying the night sky, first and foremost, see what you can find. Can you first find the Big Dipper? Whatever season it may be, point to Polaris. And then you'll see your way north. You'll see what early people saw and count your lucky stars that it's that easy. If you've got any questions, please feel free to leave them in the section below. In the meantime, Space Cadets, keep looking up.